Welcome to another video. In this video, the discussion surrounds that of marble, a metamorphic rock, specifically metamorphosed limestone and potentially or possibly dolostone. Why I'm focusing on marble is because in the context of this particular case, this rock was found within the vicinity of the Bellas Gate gold mine that I had visited earlier in 2025. A key thing that I want for you to gather is this. Metamorphic rocks originate as a result of a change in the temperature and or pressure of original or pre-existing rocks. In this case, the pre-existing rocks could have been limestone and or dolostone. So to see metamorphic rock in the form of marble indicates that the heat and or pressure change would have been sourced via the inlier itself, the central inlier to be specific. These veins, as we can see here, highlighted by this lighter hue gray, surrounded by the darker hue, is a representation of chemistry change, if you will. Basically, it's a case that the rock in of itself would have undergone the change in its overall texture. So that is basically proof that it was once a different protolith. Now, as you can see here, this indentation is a key highlight for me because this represents that this rock would have been that of karst. And in the context of geologic history or the geologic makeup of a landforms or landscape, karst landscape indicate that it would have developed as a result of being in what we call shallow water or marine systems. So it would have been near the surface. That's how you have karst. But to have karst near the surface and yet to be metamorphosed as is provides a degree of a headache, because for metamorphism to generally take place, again, pressure has to be present. And if it's a case then that we have, say for example, the original protolith just fully near the surface, then the lack of pressure would mean therefore that it is not significant for it to be able to become metamorphosed or become marble. So how is it that we have a protolith of karst carbonate becoming marble? Now, as you allow that question to simmer in your mind, allow me to present to you other key considerations. As you can see in this video, the elevation is way above sea level. To be specific, it is within the region of 600 meters plus above sea level. Now, as you look at this image, what you see are deposits of carbonate minerals. And this is specifically within the Stamford Hill mine that is within the Bellas Gate area. This, rather, where I took this image would have been in the region of, let's just say, 400 meters above sea level. So in other words, it is underneath where I was standing as regards to where the marble lithology is located. Now keep this in mind that the geology surrounding the Stamford Hill gold mine is that of andesite, and in that respect, it basically is igneous in nature. So in other words, it has a origin to volcanism. And in that respect, that gives some insight in terms of the temperature source for, let's say, the marble to have become what it is today. The thing that we need to look at here is that in terms of the presence of carbonate minerals within the Stamford Hill mine gives indication that the overall location would have been underneath the sea and I've already gone in depth in this in a previous video. But the real thing I want for you to gather is that the timing or the geologic history does not reflect that, let's say, the marble would have been younger than, let's say, the igneous source, be it within the, or represented rather, as the Stamford Hill mine. I put it that it basically is that this carbonate source would have been older, or at the very least would have been present along with the genesis of the volcanic or magma plume slash intrusion. So this gives insight in terms of why it may be that we can see that close interaction as it regards to carbonate minerals being found within the mine itself, as well as the fact that we can see the metamorphic rock some 200 plus meters above. But the other thing that you have to now note, and what is even more so significant within the context of precious metals and where they are found, is that the presence of the marble indicates that there could basically be a wider spread deposition of precious metals as well. And this is now where I am going to turn your attention to the representation of where the spatial locations of minerals are, as reported by the Mines and Geology Division of Jamaica, and actually link that to this story that I'm sharing with you now. To narrow my focus, my area I am specifically paying attention to is within the central region of Jamaica, specifically St. Catherine, Clarendon, St. Anne, and Trelawney, and specifically the economic minerals of focus are the metallic as well as marble. Pay attention to the images. Metallic occurrence. This is on the boundary of Clarendon and St. Catherine. Specifically, this is gold. Marble. This is located south relative to the Stamford Hill mine. As a matter of fact, this area is located near to Planters Hall, and I had another video discussion about this. So that's what makes this even interesting. Marble, Clarendon, Braziletto, to be specific. Marble, Roderson Store, Clarendon. Marble, Point Hill, St. Catherine. Marble, Lumsden, St. Anne. Marble, Cockold, Manchester. Marble, Stuart Bay, Trelawney. Here is a picture. Marble as the metamorphic form of limestone and or other carbonate rocks exists throughout the central sphere of Jamaica, as I would have been focusing. So St. Catherine, St. Anne, Clarendon, Manchester, and Trelawney has sources or proof of marble. Now for marble, again, to be present, there has to be a high source of temperature and or pressure. So all of this area would have been under water because obviously it's carbonate source in terms of the protolith. And basically speaking, all of this area basically would have been intruded or cooked by an igneous source or volcanic source. In terms of the timing is under question as to whether or not this marble era or the marble rocks themselves are younger than the igneous source. But take it into the realm of the metallic minerals as well as their dispersal or their location. And what you generally will see is that there exists metallic minerals relatively close to where a good number of these marble occurrences are. And that basically now gives a wider scope in terms of the full extent surrounding where metallic minerals can be located within the areas or the parishes as I've discussed in Jamaica. And another thing too is that for the marble rocks to be in close association with, let's say, non-metamorphosed carbonate rocks, this gives representation that Jamaica's origin, geologically speaking, is not homogeneous or just based on one specific timing of volcanism and one specific timing of being underwater and one specific time of uplift, etc. It just goes to show that there is a high degree of heterogeneity or complexity in Jamaica's origin. And, this is basically the more I go into trying to create these videos and tell a story, the more it just shows me that, we still have so much more to learn as regards to what is the origin of Jamaica and what really has, in the context of Jamaica's mineral wealth and or non-mineral wealth, what really is the potential of it all. So this is definitely an eye-opening experience, not just telling the story, but even me learning about it myself and getting validation here, and at the same time being brought to a corner whereby I have to go back to the drawing board and to even go back into the field and to continue the work. So, yes, let me know your thoughts. Until next time.